What if I told you that your Nvidia GPU's video random access memory could act like swap space on Linux, the same way your computer's hard drive does when you run out of random access memory? That's right. Until now, swap space was strictly the domain of your system's storage, but a new tool from GitHub is changing that. This technique, called nbd-vram, lets your GPU's video RAM serve as a temporary memory buffer, effectively turning it into a swap space. Think of it like this. Your GPU is like a high-speed courier delivering data to your CPU, but when there's too much data, instead of slowing down, it starts using its own temporary storage, the video RAM, to offload the excess. This is a big deal for developers and AI researchers who need massive memory capacity but don't have enough RAM. And here's where it gets interesting. Traditionally, swap space on Linux has been managed through your hard drive or SSD, but that's slow compared to the speed of video RAM. Video RAM is much faster than traditional storage, and using it as swap space can significantly improve performance for memory-intensive tasks like AI training or 3D rendering. This is especially useful for Linux users who are pushing the limits of their hardware. For example, if you're running a deep learning model that requires more memory than your system has, instead of crashing or slowing down, your GPU can step in and use its video RAM as a temporary buffer. This is like having a second brain for your computer, one that's much faster and more efficient. But here's what most coverage gets wrong. nbd-vram works by leveraging a technology called Network Block Device, NBD, which allows your GPU to act as if it's a storage device. This means your Linux system can treat the video RAM as a swap space, just like your hard drive. The process is handled through a kernel module that communicates with the GPU, allowing the system to read and write data to the video RAM as needed. Think of it like a high-speed courier who can quickly deliver and pick up data when needed. This is especially useful for tasks that require a lot of memory but don't have enough physical RAM. And this is where it gets complicated. Imagine you're training a large AI model on your Linux machine. If your system runs out of RAM, instead of the model crashing or slowing down, your GPU can step in and use its video RAM as a temporary buffer. This is like having a second brain for your computer, one that's much faster and more efficient. This technique is also useful for developers working on complex simulations or rendering tasks that require massive memory. For example, a 3D artist working on a high-resolution model might use video RAM swap to keep their application running smoothly without relying on a slow SSD. And this is where things get surprising. Traditional swap space on Linux is much slower than video RAM swap because it relies on your hard drive or SSD. Video RAM, on the other hand, is built to handle high-speed data transfers, making it much faster for memory-intensive tasks. For example, if you're running a deep learning model that needs more memory than your system has, video RAM swap can significantly reduce the time it takes to process data. This is especially important for developers and researchers who need to push the limits of their hardware. But here's the thing that changes everything. This innovation could change how we approach memory management in Linux systems, especially for AI and machine learning tasks. By using video RAM as swap space, users can avoid the limitations of physical RAM and still maintain high performance. This is a game changer for developers who need to run memory-intensive applications on hardware that might not have enough RAM. For example, a researcher working on a large neural network might be able to run their model on a system with less RAM by leveraging the GPU's video RAM as swap space. And that's just the beginning. Setting up video RAM swap using nbd-vram is a straightforward process. First, you'll need to install the nbd-vram package from GitHub. Once installed, you can configure the kernel module to communicate with your GPU. Then you'll create a swap file using the video RAM, which your Linux system can treat like a traditional swap space. This process is similar to setting up a swap partition on your hard drive, but instead of using storage, you're using the GPU's video RAM. Think of it like creating a temporary memory buffer that's much faster than your traditional swap space. Now here's where the real story starts. This new technique is just the beginning of what's possible when we start thinking differently about memory management on Linux. By using your GPU's video RAM as swap space, you can unlock new levels of performance and efficiency, especially for AI and machine learning tasks. This could be a major breakthrough for developers and researchers who need to push the limits of their hardware. As this technology continues to evolve, we may see even more innovative ways to use video RAM in Linux systems. And this is what nobody predicted.